is trying to figure out what or how you're going to set up your equation, but also like what's important. What's important. So this question is broken down into like an ABC, and I think that that's helpful. So Alina is gathering up change that she has saved. She has a total of $2.60. I think that that's important. That's something that maybe I'm going to underline. So I know that all of her money, all of the money that she has is $2.60. So she has a total of $2.60. It also says that all of her change is either in nickels, dimes, or quarters. So I think it's important to talk about nickels. How much money is a nickel? 5 cents. How do I show that in terms of a dollar? So it's not 5 with the little c, but it's 0.05, right? With like, does that make sense? That's how we show it in a decimal form. So that's what a nickel is worth. What about a dime? What is a dime worth? 10 cents. So that's going to be represented by 0.1 or 0.10. And what about a quarter? 25 cents. Okay. We're on page, this is the wrong packet. This is your first packet. Where's your next packet? Okay. So it says in there that she has twice as many dimes as she does quarters and 2 less quarters than nickels. So we're going to jump to question A. Perfect. Here we go. Here's where you should be okay, buddy. I didn't mean to bump your nose. Okay. So question A says, is it possible that Alina has 8 dimes, 4 quarters, and 6 nickels? Explain. So 8 dimes looks like this. 4 quarters looks like this. And how many nickels does it say? 6. And 6 nickels. So how much money is 8 dimes worth? 8 dimes is worth how much money? 80 cents. Okay. How much money is 4 quarters worth? $1. And how much money is 6 nickels worth? 30 cents. If I add this all together, what is my total money? What is it? 210 or $2.10. How much money does it say she has? So is it possible that she only has this much? No, not possible. And we're going to say why. Because it does not equal $2.60. Does that part make sense? Okay. So part B says, is it possible that Elena has 12 dimes, 4 nickels, and, 4 quarters and 8 nickels? Is that possible? What do you think about that one? How do you want to set that up? Say it nice and loud. 12 times 10 cents, okay. Keep going, Loriana, you got it. 4 times 25 cents. And 8 times 5 cents, okay. So how much money is 12 times 10 cents? How much money is that? $1.20. Good job. What about 4 quarters? How much is that? $1. What about if I have 8 nickels? How much money is that? 40 cents. What is this total? This total is $2.60. Is that how much money she's supposed to have? Yeah? Okay, but let's read something because we didn't really read this. It's in the problem, but I didn't read it. It says she has twice as many dimes as quarters. Twice as many dimes as quarters. So how many quarters does she have here? She has 4. How many dimes does she have? Is 12 twice as many as 4? No. So this is not possible because this is for a different reason. It totals up to the right amount because she does not have twice as many dimes as quarters. And I'm going to write below that, just so you know, she has 12 and 4. 12 does not equal 2 times 4, right? Because that's what twice means, correct? So 12 does not equal 2 times 4. So that one's not possible either. So now we're going to have to, in this part C, it says if the number of quarters Alina has is represented by the variable n, so we're going to let n equal the number of quarters. We have to set up an equation that's going to let us solve for each type of coin. I think that these are probably some of the most challenging questions because not only do you have to remember how much each coin is worth, right, the monetary or the dollar value of each coin, but you also have to figure out how each coin is represented in terms of the variable. So let's figure out what was the comparison that was used for the number of dimes? So what does it say about the number of dimes? Go back up to the very top. It says all of her change is either nickels, dimes, or quarters. But what does it say specifically about her dimes? She has twice as many dimes as quarters. So if the number of quarters is represented by n, how do I show the number of dimes? Twice the number of quarters. Twice n, which is the same thing as 2n. Okay. Now let's figure out about the number of nickels. Let's figure out about the number of nickels. Okay. So what does it say about the number of nickels? What's the comparison up there? It says, go ahead. 2 less quarters than nickels. So that means that, does she have more quarters or more nickels? She has 2 less quarters than nickels. So which one is more? Nickels. She has more nickels. How many more? 2. So I take the number of quarters and I add 2. So what's that going to look like? The number of quarters added to 2. What is the variable that represents the number of quarters? N. So it's just going to be n plus 2. N plus 2. Are you guys awake this morning? Kind of, barely. All right. So now we have to write an equation to solve for the number of types of each coin. So let's start with the number of quarters. How much is a quarter worth? 25 cents times n plus, how much is a dime worth? 10 cents. And what variable expression are we using to represent a dime? 2n. 2n. So 0.1 times 2n plus, how much is a nickel worth? How much is a nickel worth? 5 cents. And what variable expression are we using to represent nickels? N plus 2, so I have 0.05 times n plus 2. And how much money do I have all together? How much money did she say she had all together? $2.60. All right. So we have to get rid of those parentheses first. We can't do any kind of combining like terms or any of that until we get rid of the parentheses. So this is a multi-step equation. So remember, if I have parentheses, the only way to get rid of them is to distribute. The only way to get rid of them is to distribute. And I try to always draw arrows when I'm distributing. That makes me like force myself to actually multiply everything, right? I don't want to skip any terms. So am I doing anything to the 0.25n? Nope, that's just going to stay exactly the way it is, 0.25n. If you have a calculator, someone tell me what 0.1 times 2 is. 0.1 times 2. It's 0.2n. So 0.1 times 2, that's going to give me a 0.2n plus. Now I'm right here. I need to know what 0.05 times n is. What's that going to look like? 0.05 times n is 0.05 n plus, and now we're doing this piece. We're taking 0.05 times 2. 0.05 times 2. What is that? Use your calculator. 0.05 times 2. Point 0.1, right? 10 cents? Yep, perfect. Equals $2.60. Equals $2.60. So now let's talk about some combining of like terms. Let's see. I can take my n's and add all of those together. Can someone add those decimals together, the ones that we have underlined? So 0.25 plus 0.2 plus 0.05. Are you writing any of this down? Where's your note packet? Miss Benko, does he not have a note packet?
He did.
Open up. Where's your note packet?
Hang on. He left stuff in my room
Okay.
already, so I think it's in my bag.
So 0.25 plus 0.2 plus 0.05. Yeah, it's 0.5n. Plus 0.1 equals 2.60. Okay. So now what do you want to do? We're trying to get in the number of quarters all by itself. What do I have to move away? Yeah, I'm going to subtract 0.1 from both sides. Página 11. Por favor. So 0.5n equals, what is 2.60 minus 0.1? It's 2.5. 2.5. Now what are we going to do? What are we going to do, hon? Divide. We're going to divide both sides by what? We're going to divide both sides by 0.5. I want you guys to have a calculator. I'm going to turn them on here. So I'm going to divide this side by 0.5. And I'm going to divide this side by 0.5. So n equals n equals 5. Did you guys get that? Okay. So how many quarters does she have? 5. She has 5 quarters. Okay. If she has 5 quarters, how many dimes does she have? 10. 2 times 5 is 10. And if she has 5 quarters, how many nickels does she have? 5 plus 2 is 7. Good job. 5 plus 2 is 7. Whew, that was a lot. That was a lot. I'm going to leave that there for a second to make sure everybody has that. I'm going to freeze that and leave it up there for a second. On Friday, I know that you guys took your quiz, but I also asked you to fill out your 1.3 journal page, right? And your journal page was about perimeter and distance and average. Perimeter, distance, and average. Okay? So, are we all ready to go into the next question? Everybody good? Okay. So the next question says that someone drove to work what does it say? Someone drove, I don't have my notes. Can I read over your shoulder? I'm sorry. Eva drove to work at an average speed of 36 miles per hour. On the way home, she hit traffic and she only drove an average of 27 miles per hour. Her total time in the car was an hour and 45 minutes, or 1.75 hours. How far does she live from work? So I'm going to kind of draw a picture, first of all. So maybe I'll start off with a little car. So here's my car. I know it's pretty sketchy looking, but she drives to work, and then she drives back to home. That's kind of how her trip goes, right? How fast does she drive to work? 36 miles per hour. And that is her rate, or her speed. So that stands for the value R. I'm going to actually just write out the word her rate. Okay. But what about on her drive home? How fast is she going on her drive home, Peter? She's going 27 miles per hour. Peter, you're really struggling staying awake. That's the second time I've looked at you and your head is bobbing. If you need to stand up, feel like you can do that, okay? Or go get a drink of water, you can do that also. Okay, so I want to talk about the distance formula, that we use for speed, right? So we know that the distance that you travel is equivalent to the rate, the speed that you're going, multiplied by the time. Okay? We're trying to figure out how far she lives from work, and we know some really important things. We know her rate, her speed that she drove to work, and we know her rate or her speed that she drove home. We don't know the time on her drive to work. We only know the total time. We know that her total time is 1.75. Okay, so we're trying to figure out the distance. So we have to write kind of an equation for each. So on her trip to work, her distance equals her rate, 36 miles per hour, times t. Some time. We don't know how long it is. We just know that she spent some time going to work. Okay? What's her formula or her equation for her drive home going to look like? Well, her distance equals her rate, 27, multiplied by, we don't know how long she drove to work. We don't know how long it took her to get home, but we know that the total trip there and back is an hour and 45 minutes. So if I knew that my whole trip was 1.75, and I knew that I spent 0.25 minutes, 0.25 hours to get to work, what would this be? If I knew that the top, I was able to get to work in 15 minutes, how would you figure out the bottom? Say that. You would subtract. So we're going to take our total time minus the amount of time it takes me to get to work. So we're going to write 1.75 minus t. So that's what we're gonna put in that parenthesis, 1.75 minus t. That will let us figure out how much time she spent on each trip, like on the way there and on the way back. So there's something really interesting about this. Do you guys see that you have two equations, both start with a d equal? Right? Your distance is this, your distance is that. Well, if they both equal d, if both of these equations represent distance, then that means I can set them equal to each other. Meaning that 36 times t equals 27 times 1.75 minus t. Because if d equals 36t and d equals 27 times 1.75 minus t, then those two things have to equal each other because d equals d, right? So how am I going to solve this? How am I going to find out how much time she spent driving to work? I have to distribute first. So 36t equals 27 times 1.75 is? What is it? 47.25? Minus, let's see, 27 times t is 27t. Now, this is the first time that we've actually had an equation with variables on both sides. And that's really kind of an example for our next lesson. But I want to talk to you about it anyway. So remember that when we solve an equation, you want to get all of the variables on one side and all of the constants on the other. So if you look at this equation right up here, you have the 36t already all by itself on this side. But on the other side, you have a constant and a variable term. I need to take this variable term and move it to the other side. If I move something across the equal sign, I have to use the what kind of operation? Opposite or, oh, did you say opposite as well? I said inverse. The opposite or the inverse, yes. So what is the opposite of minus 27t? Add it. So we're going to add 27t to both sides. So when I do that, 63t equals 47.25. 63t equals 47.25. How are we going to get the time that she traveled to work, because t just represents her time for work? How are we going to figure out what t is? Yeah, we're going to divide both sides by 63. We're going to divide both sides by 63. And I find out that t equals 0.75 hours. I need to think about that looking at a clock. So if I were to look at a clock, if I were to draw a clock, and this is 12, this is 3, and this is 6, and this is 9, and I were to do this, break my clock up into 15-minute intervals. This is 15, this is 30, this is 45, and this is 60 minutes. How much time is 0.75 of an hour? Say it, Aiden. 45. It's 45 minutes. Yeah, 0.75 of an hour is the same thing as 45 minutes. So it takes her 45 minutes to get to work. But that's not really the question. The question isn't how long does it take her to get to work. The question is, how far does she live from work? So we know that the trip to work that was your rate of 36 times 0.75, which is equivalent to 45 minutes. And we know that her trip home was 27 times 1.75 minus the time that she spent going to work. Either one of those gives us our distance. Either one of those, because remember these were set up as 36 times t equals d, 27 times 1.75 minus t equals d. So what is the distance? What is my distance? Distance is in miles. So it's 27 miles. Good job. Distance is 27 miles, and it doesn't matter if I plug in and solve for the bottom one or if I solve for the top one. I get the same exact answer. My distance is 27 miles. That means on the way to work, she drives 27 miles, and on the way home, she drives 27 miles. It's just that she's able to get there faster on her way to because there's less traffic and she can go faster. So she can get there quicker, right? Because she has a faster speed. Okay, I'm going to freeze that, leave that there for a second. I'm going to go up to the next one. We have two more examples. We're going to do example 3 and 4. We're going to do examples 3 and 4. Raise your hand if you need more time on number 2 to write it down. Okay, I see you. Just hurting. You good? Thank you, sir. Okay. So we're going to do number 3. Number 3 has to do with average. Number 3 has to do with average. So I want to talk about what average is. So average. Come on. Oh, come on, for Pete's sakes. Okay, so average. So who can tell me when I say the word average, what does that mean in terms of math? How do we find the average? Peter.
Add up all the numbers that you're using and then divide it by how many numbers you have.
Perfect. So Peter said, add up all the numbers in your set. And when I use the word set, I mean just like Peter said, whatever numbers you're given, whatever numbers you're using. And then you take that sum and you divide it by the number of terms or numbers in your set. Okay, so how many numbers are we adding together? How many numbers are we adding together here? What does it say? We're adding 3 numbers together. So I don't know what they are yet, but I know that I'm going to add 3 numbers together. So if I'm adding 3 numbers together, what do I divide by? You divide by the number of terms that you add together. So how many numbers am I adding together? 3. So I'm going to have to divide by 3. So if I add these 3 numbers together and divide by 3, what does it say their average is? What does it say their average is? It's 14. So this has to equal 14. Now, because this is math 1, it's not going to just say, hey, your numbers are blah, 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 blah. It's going to make you think about what the numbers are. So I think our numbers are written in terms of like a small, a medium, and a large. So who wants to read to me that first sentence after the number 14, where it says the smallest number? Who wants to read that? Elisha, you want to read that for us? The smallest number? Turn right here, just that first sentence. Please and thank you.
The smallest number is less than the middle number.
Okay, that's good. Smallest number is 6 less than the middle number. So what does that mean? If it's 6 less than the middle number, I'm going to erase where I put medium and change that to middle. How would I show 6 less than the middle number if I let the middle number be the variable x? If I said the middle number was x, how would I show what the small number is? Yeah. So if the middle number is x, the small number is 6 less than that. So it's going to be x minus 6. Okay? Who wants to pick up where it says about the large number? Who wants to finish reading that statement about the large number? You want to read it, Lorianne? The largest number is 4 less than twice the middle. 4 less than twice the middle. You need to keep your head up. Okay? When I'm happy. 4 less than twice the middle. How do I show that? 4 less than, that means I'm going to do what? 2x minus 4. Good job. Perfect. Okay. So those are the variables that represent the 3 numbers I'm adding together. So the first number that I'm adding together is x minus 6. The second number that I'm adding together is x. And the third number that I'm adding together is 2x minus 4. Okay. So now what do you want to do? We have to solve that. How are we going to solve something like that? Say again. Yeah, good job, ladies. We're going to combine the like terms. So let's try and think about all the things that we can group together. So I can probably group up all of my, what? My x's. Okay. So x plus 2x is how many x, Jamari? 4x. Good job. And then what about my constants? What about my 2 constants? What's a -6 and a -4 equal? -6 and -4 is -10 all over 3 equals 14. All right, now we have a nice equation that we can work with. I cannot do anything with the variable until I get rid of the denominator. So Francisco, how am I going to get rid of the denominator? What is the inverse or opposite of divide? Opposito dividir. Okay, so what's the opposite? ¿Cómo se dice opposite? Isn't it oposito?
Opuesto.
Opuesto. What's the opposite, opuesto, of divide?
Opuesto de dividir.
Perfect, multiply. So we're going to multiply both sides by 3. We're going to multiply both sides by 3. So that means I'm going to multiply this side by 3, and I'm going to multiply this side by 3. So that's what we have to do. When I multiply the left side by 3, we do that because we want the denominators to cancel out. So I have 4x minus 10 equals, let's see, 14 times 3 is 42. Now what are we going to do? I'm trying to get x all by itself. What am I going to do now, Aiden Smith? What should I do? I'm trying to get x all by itself. What should I do first?
Subtract 10 on both sides.
It is a subtract 10. So what's the opposite of?
Add 10.
Good job. We're going to add 10 on both sides. We're going to add 10 because remember when we try to cancel out or use the inverse. So that means that 4x equals 52. Andrew, what's the last step? 4 times x is 52. Good job. We're going to divide both sides by 4. So x equals, what is 52 divided by 4? 13. Okay. So let's look at what our numbers are. That 13 represents the middle number. So the middle number is 13. What is the smallest number? What is x minus 6? Or 13 minus 6? It's 7. So the small number is 7. And what is our large number? 22. 2 times 13 is 26. Minus 4 is 22. So these are the three numbers that we added together. These are the three numbers that we added together. I'm going to leave that there for a second. Raise your hand if you need more time writing that down. Do you have that all written down? Let me know when you're done, okay? Jamar, do you have number 4 solved already? Almost? Good? Okay. All right, so let's do number 4. Who wants to read number 4 for me? Anyone want to read that? About Jem and his rectangular garden? Go ahead, Loriana. Okay, so let's talk about perimeter first. How do I find the perimeter of something that's, how do I find the perimeter of a rectangle? Add up all the sides. Okay, so let's draw a rectangle really fast. Let's label the sides. Let's see, my sides are either the width or the length, right? It's either a W or an L. Width and length. So if I wanted to find the perimeter, I have to take 2 times the width plus 2 times the length. Okay? 2 times the width plus 2 times the length. So how much is the perimeter? Does it tell us what the total perimeter is? P equals 170. So I'm going to write that. P equals 170 feet. Does it tell us anything else about, God bless you, does it tell us anything else about the dimensions? Go ahead. So right here it says the length is, that means L equals 10 more than twice the width. So how do I show 10 more than twice the width? (2W plus 10). All right. So we know that the perimeter, we're going to use this equation, P equals 2 times W plus 2 times L, and we're going to substitute in the things that we know. What is my perimeter? 170 feet. So this is going to become 170 equals 2W. You should be writing this down, bud. This is number 4. So put this up here. 2W plus the variable L is represented by the expression 2W plus 10. I need a whole cheat sheet of words. Like I need to remember my vocabulary, my alphabet, and my, yeah.
Longitude is what I use, and then anchura for width.
Okay, anchura and longitude,
Longitude like
like longitude, okay. So how are we gonna solve this? Distribute. Okay. So Jamari, when you distributed, what did you get? So 2 times 2W is 4W plus 20. 2 times 10 is 20. Good job. Can I combine any like terms, Braden? What? What is 2W plus 4W? So 170 equals 6W plus 20. What do you want to do next, Riley, to get X all by, or W, sorry. What do you want to do next to get W all by itself? Good job. Subtract 20 from both sides. So 150 equals 6W. 150 equals 6W. Ariana, what do you want to do next? We're going to divide both sides by 6. I love that. We're going to divide both sides by 6. So my width equals what? Marco? I didn't hear. 25 what? Donuts? Peanut butter sandwiches? 25 what? What's the unit? Feet. So my width is 25 feet. And that means that my length is what? How do I find the length? Well, I have to take 2 times my width plus 10. So what is my length? 60, just regular feet. It's not square until we find the area. It's just regular feet, 60 feet. Okay. So this question says, hey, I need you to find the area of the rectangle. I forgot how to do that. Who knows how to find the area of a rectangle? Area. Someone other than Loriana. Go ahead, Braden. What is it? Yeah, the area equals the length times the width. So if our length is 60 feet and our width is 25 feet, what is our area? Say again. 1,500 square feet. 1,500 square feet. 1,500 square feet. Okay. I'm going to leave that there for a second. I'm going to give you guys your worksheet. Now, we have quite a bit of time. We have 40 minutes, just like the last one. Perfect. 40 minutes. So I'm going to give you your worksheet. There are 10 questions on it. I'm going to do 5 of them with you. But I want you to read through them and choose the 5 that you want to see. Tris, you don't need to stand there. Right? Not at all. Okay. you want yours in Spanish? Parker, do you want yours in Spanish? I'm teasing him.
Do you want me to isolate those same problems we talked about?
Yes.
And take them all to my class and go through
Do you,
the
do you want me to, we're gonna do 1, 2, 3 together,
Okay.
and then you wanna take them? Is
Yeah,
that okay?
I think so.
Okay.
I think that makes sense.
I think that's good. All right, so let's do questions 1, 2, and 3 together. And then you can pick, 'cause I'll do 5 of them with you. So let's do 1, 2, and 3 together, get your like math brains turned on. And then you can pick the other 2 that you want to see. Is that okay? Yes, Miss Bischoff, that sounds great. Perfect. Let's do that.